can now open it to questions. I see there are a few questions. I don't know, yeah, Sebastian, do you want to take yours first, or?
Yeah, thanks, Adrian, for the nice overview of showing us how to scale the PyTorch code to, let's say, the next level. Yeah, I was briefly looking at the Q&A here on the right-hand side, and I think we can just go through the questions instead of, let's say, typing them. We can maybe read them out loud and just answer them. So I can maybe start at the top. So there was a question, which activation functions have we used and why? So there were, I think this maybe about my portion of the talk. So I used activation functions in two parts. One was the computation graph. Let me maybe see if I can share my slides, and then can go through that. So here we used the logistic sigmoid function. The reason is to keep it simple, to have like a logistic regression model. There's no particular reason except it being a logistic regression model. I could have shown a different model here. For the other part, the activation function here, so we have the ReLU functions here. These are usually, yeah, good out-of-the-box activation functions. There are, of course, different activation functions nowadays, like GELU and CELU and so forth, that also work well, or leaky ReLU. For me personally, ReLU is usually something to start with, and then using other activation functions is usually a hyperparameter, I would say, that you can experiment with. For example, transformers use GELU quite a lot, but ReLU, in my experience, for convolutional networks usually perform very well. Here in the output layer does not have an activation function, and that is because, like I showed you here, the cross entropy will automatically take care of that. So it will automatically use a softmax internally. So the activation function, if you use cross entropy, will be a softmax if you set it up like that. You have to be careful not to add the softmax here explicitly, though, because the cross-entropy loss will automatically take care of that. Yeah, so I hope that answers the question. And the reason why softmax, it's because we had a classification problem here, the MNIST dataset, where we had multiple classes. But there's also a binary cross-entropy. If you only have two classes, you could also technically use that one. Another question was when we use nn.Sequential, and so when do we, so let me just read it out. When and based on what criteria have we selected nn.Sequential and nn.Module? So the question is, I think, about here the module. And this is something that we always need to do when we define a neural network in PyTorch. And the reason is that it will give us certain functionality. So for example, one functionality was calling dot parameters here. So in order to make this work, there has to happen something inside the class. And notice that we have not defined anything ourselves that has parameters or dot parameters. So this comes all from this nn.Module parent class. Another thing we don't have here, when you look down here, is we call dot backward. However, we have not defined dot backward ourselves. We only defined dot or the forward method. So again, module will take care of backward automatically for us based on the forward method. This is why we have to use torch and nn.Module, because it gives us these certain things for free. The other question was why we use, or when do we use nn.Sequential? So personally, I use that most of the time if I have a very straightforward network. So if I have something where everything gets executed in this order that I can specify here in a linear order, then I would use sequential, because it's just easier compared to this version where I define a few layers and then I have to manually say how I execute them here in the forward method. Which, I mean, this is the same network. It's just a little bit more, I would say, tedious, and there's more room for making errors by making mistakes here. If you have the sequential, you know it gets exactly executed in that right order. There are cases, though, where, let's say, you need something special, where you don't necessarily want everything executed in a certain order, you want to make modifications. And that is where it's useful to do forward more explicitly, like here. On top of my head, one case where I do a setup that is more like that is when I have, let's say, a variational autoencoder. I would have an encoder and a decoder, maybe a sequential, but when you have the mean vector and the variance vector, I would usually have them as separate layers and put them in here, because then you can do the reparameterization trick as a separate function and so forth. So that is like more like an advanced topic, but every time I would say you need something special, then it's good to know that you can use this forward method and you don't have to use sequential. Sequential is just there to make your life easier. It's an option. You don't have to do it. Yeah, okay. Oh, a good question. Is the Dev conference free? I think it should be free, but I'm not sure if we have tickets left. There were another person asking. I think there were no tickets left. I actually, on our Slack channel, I just asked the question, but I think, yeah, we will figure it out. I don't think we have. So we had a few tickets for travel expenses. We don't have those anymore. They ran out, but I think we have some tickets still available if you are in New York City. So maybe just reach out to us. We will get back to you about that. If you're interested, if you're in New York and you want to attend, that should be free to attend. Yeah, and there should be an email address when you go to the website that you can email, and they will help you with that. If you are not in New York, for example, and you want to attend virtually, I think we will also have a stream, a live stream virtually. I think more instructions will follow. I will be in touch with the people, and if there's an email address, email the people there. We will make sure you get a response. I will, after this talk, also talk to everyone to make sure that everything gets answered. Okay, so the next question would be, why do we have a static validation set rather than cross-validation? That's a good point. Cross-validation is usually very useful to prevent overfitting. In deep learning, it's more common, though, to work with a training validation test split. And that's because deep neural networks are expensive to train. If you look at the forward pass that I showed you, it is more work to set it up to do k-fold cross-validation, right? Because you would have to have something about the training loader where it only loads the specific folds, and then you have to have another for loop iterating over the folds, which is kind of tricky. And people, I mean, usually networks can train multiple days or multiple weeks sometimes, and that could be expensive. Another thing is, if you do k-fold cross-validation, you have multiple models, right? So if you have 5-fold cross-validation, you will have 5 models, each of the models trained on different folds. So which would be your model that you end up using, let's say, in production? What you could do is you can make an ensemble of these 5 models. But again, this is like making things a little bit more complicated, and which is, I think, why most people don't use k-fold cross-validation when they do deep learning, because they really just want one specific model, and also it makes it easier to monitor the performance of that specific model, making sure it converged. If you do k-fold cross-validation, you have to monitor all 5 models, that they all converged and so forth. However, it is possible actually to do that. I have actually last weekend toyed around with a demo, and I will, in a few seconds, I will share the link with you, and then if you're interested, you can actually use k-fold cross-validation with PyTorch Lightning. So it's actually PyTorch Lightning code, because in PyTorch it would be way too complicated to implement that. So I have the link right here, and I will just put it maybe in the chat. If you're interested, that's how you would do k-fold cross-validation. It's just a little bit more, I would say, requires a little bit more setup, but with this library I'm using there, it's actually pretty easy. So with PyTorch Lightning. Yeah, and then Reshma had a question, reducing, so basically whether 16-bit precision is the same as quantization, and I think Adrian can maybe answer Reshma's question here better. So, and also I can take a sip of water and take a little break before we go to the remaining questions.
Yeah, sure. So quantization, yeah, that's interesting. I don't have practical experience with quantization, but what I know is basically quantization is mainly for inference. So to speed up inference, basically. And the mixed precision, however, is more for training, because during training, we not only evaluate the model, we also need to do backpropagation. And we don't want that there are numerical instability issues with the gradients, because if the gradients get affected by this, this can have very bad influence on the training of the model. So actually there are, it's called mixed precision, because some operations need to have the full precision, 32-bit, but some operations don't need it. And that's why PyTorch converts them. And PyTorch knows basically which operations can have this lower bit precision. And so this makes it useful for training. But quantization is actually more extreme. It goes down to even 8-bit precision. And it's very difficult to train neural networks with this low bit precision because of how it affects the backpropagation and the gradients. So yeah, I would say that's the main difference, that quantization is more used to speed up the inference. So when your model is finished training and you use it in the real world, you can like save memory and you can compress it and you can use it on mobile phones and so on. So that's why quantization is useful. And the mixed precision is more for training. Yes. And then I think there is another question. So after creating multiple models, we define them in the run method of lite, and we get our experiment results at lightning speed, at speed of light. Yes. Yeah, you can actually use multiple models. That's totally fine. So for PyTorch and for LightningLite, it actually doesn't matter how many models you use. It's just, you just build this computation graph that Sebastian showed you in the slides, this graph of computations, and that's what PyTorch only cares about, only this graph. It doesn't matter how you split it up into different models or layers. So yeah, that's basically it. And then the last question is how do we measure, validate PyTorch performance? Yeah, so performance is a big word. So I'm not sure what you mean here. So there is the performance in terms of speed of execution, right? Or the performance in terms of the performance of your model. So how well it does on your test set. So to measure the performance of execution, so there are some tools in PyTorch. There are profilers that can tell you how much memory is your PyTorch program using. And it also can tell you how much time is spent on each of the computations, on each layer in your network. And this is actually called the PyTorch profiler. So if you go to the PyTorch docs, you can find that profiler. It's very useful to find bottlenecks. So sometimes you do some combination of layers or computations that are inefficient and can actually be simplified. So this is one way to identify that. But in general, yeah, you just measure the time it takes to, let's say, do one iteration of training, and then you average that time out over multiple iterations. So that's how you measure the performance of execution. Yeah. Cool.
I just see there is another question I totally skipped over. So someone was asking about the computational graphs. So the computation graphs I made. So the question is it really practical? No, it's a statement. It's saying, it's a really practical way to think about modeling. Could you recommend any books or resources to learn more about creating these graphs? Yeah, it is. I don't think I have anything at hand related to creating the graphs, but to be honest, it's something. It's kind of like related, like how you define things in sequential, or how you set up your forward method. It's essentially a way of just writing out the computations more explicitly, how you would code them up. However, I think there are ways in PyTorch you can actually visualize the computation graph, specifically in TensorBoard. So TensorBoard is a tool that is used originally by TensorFlow, but it also supports PyTorch. And I think there is a tab in TensorBoard that shows you, if you define the model, how the computation graph looks like. I can maybe see if I can find a web link for that. So if you use PyTorch Lightning, by default, it will use actually TensorBoard. And I think also that has the computation graph automatically created. Let me see, I probably can share this here in the chat. So it's just like a general PyTorch tutorial on inspecting the model using TensorBoard. But that way you could look at the computation graph, how PyTorch sees it. Of course, it's not such a nice drawing that we would make ourselves, but maybe that's useful. And for that, you at least know it's the correct computation graph, because it's the one you defined in code. But other than that, it's really, I would say it's about like thinking about the computation that you do. And it's a very useful exercise for me personally. If I have a complicated, let's say, mathematical equations, for me, it's kind of hard to look at these. It's always like very abstract, a lot of, let's say, symbols and numbers. I always try to, let's say, draw this and take this apart. And this is a good exercise, I think, to like make sure everything is more organized or kind of easier to look at. So I hope that helps.
Hey, so thank you so much for this amazing presentation. We had a really good turnout and a lot of questions. Do you have any, if you want to have any closing thoughts?
Just wanted to thank you, Raschka, for inviting us. That was fun. And yeah, thanks everyone for attending and being also flexible in terms of time, that we could chat a little bit about things and answer questions. So that was fun, actually.
Yeah, for me the same. Yeah, this was fun, and it's actually been a while presenting. It's really nice to do educational material like this, and yeah, it's super nice to work with Sebastian, of course. So super glad how it turned out.
Great. Thank you both so much. What I'll do is once I post the video, I'll email you both, and also we'll email the Meetup group with the video link. And if we get more information about the conference in New York, whether it's in person or virtual attendance, I will also send that to the Meetup group as well. And with that, thank you.
Yeah, thank you, and have a nice rest of the day, everyone.
Goodbye.